All right. So we're looking to the PEPs or Project Caldera. The PEPs, an acronym for potential energy pools. We have an idea for Project Caldera here. This is under Leviathan Mining Company, services modern and contemporary. PEPs are potential energy pools modernized and upscaled. Leviathan or Energy and Power Company. Could we store potential energy in colossal underground surface level or space-based battery acid pools or lakes? Design underground and space-based PEPs are potential energy pools. How can we prevent these from being sabotaged by outside malicious entities? How can we increase security measures and safety protocols to prevent them from being misused accidentally or intentionally by those who are granted security clearance to access these sites for essential work operations? So, what do we think about the following concept? Please be as detailed and thorough in your analysis as you can be. So, the analysis, the Leviathan PEP, or potential energy pool system, is a fascinating exercise in megascale engineering. We're essentially proposing a chemical kinetic hybrid of a traditional flow battery and a pumped hydro storage system scaled to a planetary or orbital level. Architectural design of PEPs or underground PEPs, the subterranean sea. Instead of standard tanks, these would utilize geological sequestration. Structure carved out of salt domes or lined granite caverns to handle battery acid like sulfuric acid or vanadium redox electrolyte. The caverns would require a multi layer polymer and ceramic lining to prevent lithospheric leaching. Energy conversion. This functions like a redox flow battery. You have two massive pools, anolyte and catholyte. When energy is abundant, such as solar or wind, liquid is pumped through a membrane stack to charge. When the energy is needed, it flows back. Space-based PEPs, the orbital battery. In space, weight is an enemy, but microgravity is an ally for liquid dynamics or for fluid dynamics. Structure, rather than a lake, which would disperse, the PEP would be a modular series of spherical tension skin bladders shielded by a Whipple shield to protect against micrometeoroids. The slingshot variation, if you want true potential energy, you use the acid's mass. You park the mass in high Earth orbit, or HEO. When energy is needed, you lower the orbit via tether using electromagnetic braking to harvest the kinetic energy. Preventing external sabotage. A lake of acid is a high value target for kinetic strikes or eco terrorism. Geographic obscuration. For underground sites, the surface footprint should be indistinguishable from standard industrial zones or even ghost towns. Acoustic and seismic monitoring. Surround the site with a perimeter of fiber optic cables, distributed acoustic sensing. Any drilling or tunneling nearby by a third party would be detected instantly by the thrum of the earth. Active denial systems, or ADS, for space-based PEPs, security would require sentry tethers, small automated drones capable of intercepting incoming projectiles or grappling unauthorized boarding craft. Internal security and insider threat mitigation. The greatest risk to Leviathan or Project Caldera isn't a missile, it's a technician with a thumb drive or a disgruntled engineer with a manual override code. The two key logic and biometric sharding. No single individual should have the power to drain the pool or overcharge the stack. Distributed authorization. Operations require simultaneous cryptographic keys from three separate departments, such as engineering, security, and external oversight. Air-gapped control systems. The physical pumps and valves must be controlled by a localized dumb network. If it isn't connected to the internet, it can't be hacked from overseas. Behavioral AI surveillance, gait and stress analysis. Use high-res cameras to monitor employees. AI can detect anomalous behavior, such as a technician hovering near a manual release valve they aren't scheduled to maintain, or signs of extreme physiological stress, um, which could, oh my God, what's the word? Which could indicate potential coercion. Security and access protocols for personnel to prevent insider sabotage, such as someone intentionally triggering a Tier 3 event. The site must operate under high reliability organizational standards, or HRO standards. The dead man digital handshake. Technicians entering the red zone, such as where pumps and valves are located, must wear haptic suits. If the suit detects a sudden spike in heart rate not associated with physical labor, or if the technician moves toward a forbidden valve without a pre-logged work order, the system enters stasis mode, locking all physical actuators. Segmented knowledge, the puzzle method. No single technician understands the entire system's software and hardware. Engineer A knows the pump mechanics, Engineer B knows the chemical balance, and Engineer C holds the encryption keys for the OS. Any major operation requires all three to be physically present in separate shielded bunkers. Safety and security of the plant. A refinery handling millions of tons of acid and vanadium is a critical infrastructure site. The vault architecture. The entire refining core is built in a secondary containment basin, essentially a giant concrete bowl capable of holding the plant's entire fluid volume in case of a tank rupture. Vapor recovery.
Sorry, I didn't understand.
Oh, my Google Home was listening to me. Vapor recovery systems. Vanadium dust and acid mists are toxic if inhaled. The plant operates under negative pressure. All air is pulled through scrubber towers that neutralize fumes before they reach the outside world. Automated logic controllers, or ALCs. To prevent human error sabotage, the chemical ratios are managed by an air-gapped AI. If a technician tries to manually override a safety valve, the AI triggers a site-wide hard lock, freezing all fluid movement until an off-site security team verifies the command. Safety protocols and accident prevention. Self-healing liners, using smart polymers that expand and harden when they contact the specific pH of the battery acid, instantly sealing minor leaks. Rapid neutralization, surrounding the pools with sacrificial buffers, massive silos of crushed limestone or alkaline bases that can be gravity fed into the pool to neutralize acid in seconds during a catastrophic breach. Atmospheric scrubbers. Underground PEPs must have vapor traps. If the acid heats up or leaks, the resulting toxic fumes are vacuumed into scrubbers rather than venting to the surface. Emergency protocols, the Leviathan safeguards, or the Project Caldera safeguards. If a Caldera-sized acid pool fails, it isn't just a spill, it's a regional ecological extinction event. The protocols must be tiered based on the containment breach level. Tier 1, the jelly protocol, which pertains to a minor leak. If sensors detect acid leaching into the surrounding rock, there is in situ solidification. Automated ejectors fire sodium silicate or specialized superabsorbent polymers into the breach. These react with the acid to turn it into a solid, inert gel, instantly plugging the hole from the outside in. Tier 2, the neutralization blizzard, for a major surface breach. If the surface of the lake is exposed or a dam wall fails, there is alkaline bombing. Pre-installed overhead silos or dedicated aircraft drop massive quantities of calcium carbonate or limestone or sodium bicarbonate. This creates a snowstorm effect that neutralizes the pH level. CO2 management. Neutralizing acid with carbonates creates massive amounts of CO2 gas. The facility must have downwind extraction towers to prevent the gas from suffocating nearby populations. Tier 3, the thermal runaway, boiling or overheating. If the cooling system fails and the lake begins to boil, there is liquid nitrogen injections, or a liquid nitrogen injection. A network of pipes at the bottom of the lake releases cryogenic nitrogen to flash cool the electrolyte. Atmospheric lid. An automated physical barrier, such as a floating ceramic composite tarp, deploys across the lake's surface to prevent toxic acid mist from entering the atmosphere. Emergency evacuation plan. Protocol Leviathan 0 or Caldera 0. If a Caldera sized potential energy pool or PEP experiences a total containment failure, the threat is twofold: acid flooding and toxic vapor clouds. Phase 1, the golden 10 minutes detection. Seismic triggers. The moment the sensors detect a structural crack in the caldera lining, the regional siren network is triggered. Automated neutralization. Overhead silos immediately release sodium bicarbonate, or snow, to create a crust over the leaking area, slowing the flow. Phase 2, the zone of exclusion, the evacuation. The area around the caldera is divided into 3 zones. Zone red, 0 to 5 kilometers. This is the immediate physical threat. All personnel and residents must use vertical evacuation, climbing to pre-built high ground shelters rather than driving, as acid may dissolve tires and roads. Zone orange, 5 to 20 kilometers. This has a vapor threat. The primary danger here is H2SO4 mist. Is that hydrogen to silicon oxygen 4? Okay. Residents are issued positive pressure respirators and are instructed to shelter in place in airtight sealed rooms, or ATSRs, rather than flee into a toxic cloud. Zone yellow, 20 plus kilometers. Water supply protection. The focus is on sealing off all groundwater inlets and reservoirs to prevent vanadium contamination from reaching the municipal water supply. Phase 3, the scorched earth cleanup. Once the leak is stopped, the Leviathan company must deploy neutralizing foam sprayers via heavy lift aircraft. The goal is to turn the spilled liquid into an inert solid salt gypsum. Sorry, I get notifications. The goal is to turn the spilled liquid into an inert solid salt, such as gypsum, as quickly as possible to prevent it from reaching the ocean or local rivers. Critical analysis, the Leviathan hurdles. While the concept is bold, we have to address the energy density versus mass problem. Corrosion fatigue. On a lake scale, the maintenance of the liners would be a never ending, highly dangerous task. Thermal management. Charging and discharging millions of gallons of acid generates massive heat. Without a way to cool the lake, it could boil, leading to a Leviathan scale steam explosion. Space logistics. Launching enough acid to create a lake in space is currently cost prohibitive. We would likely need to harvest the sulfur or chemicals from asteroids or the moon to make it viable. Regolith mining. Yay. Scaling the PEP. Scaling the battery to the size of a caldera or a volcanic crater transforms it from a piece of hardware into a geographic hazard. At this scale, we're moving away from traditional lithium-ion, which would be a massive fire risk, and toward flow battery chemistry, specifically vanadium redox, or VRB, or vanadium redox batteries, or iron chromium systems. Here is the deep dive into the chemistry and the red alert protocols for a Leviathan scale facility. Chemical composition, the Leviathan electrolyte. For a lake-sized battery, we need a fluid that is stable, non-flammable, and has a long shelf life. The most viable candidate is vanadium pentoxide, or V2O5, dissolved in sulfuric acid, H2SO4. Why this composition? For scalability, in a VRB, or vanadium redox battery, the power megawatts is determined by the size of the membrane stacks, but the energy capacity, megawatt hours, is determined solely by the volume of the tanks. A caldera-sized lake could theoretically power a continent for weeks. The single element advantage: most batteries use 2 different metals. VRB uses vanadium in 4 different oxidation states. If the 2 lakes, analyte and catholyte, accidentally mix due to a leak, they don't explode. They just get warm and discharge back to a neutral state. If you can then reseparate them without losing the raw material. The stats per caldera. The solvent is concentrated sulfuric acid, approximately 2 to 5 moles, or 2 to 5 molarity. The solute, vanadium ions, V2 plus V2 plus or V3 plus on the negative side, and VO2 plus or VO2 plus, same thing, on the positive side. VO2 plus, VO2 plus. Okay. Additives. Phosphoric acid is often added in trace amounts to prevent the vanadium from precipitating out of the solution at high temperatures, which would turn your lake into a solid block of salt. Scale problem. To put the Caldera scale in perspective, 1 gigawatt hour or gigawatt hour battery using vanadium requires roughly 10,000 to 20,000 tons of vanadium. A large Caldera battery would be 1,000 gigawatt hours. That would require 20 million tons of vanadium, roughly 200 years of current global production. Wow. Dimensions, I mean, we could scale it up over time. It doesn't have to be like that big immediately right off the bat. Let's scale it up over time. All right. Dimensions of the 1,000 gigawatt hours Leviathan lake. To design a 1,000 gigawatt hours or 1 terawatt hour storage facility, we move from the realm of electrical engineering into civil geoengineering. This is roughly the amount of energy needed to power the entire United Kingdom for about 36 hours. The size of the lake is dictated by the volumetric energy density of the vanadium electrolyte. Modern vanadium redox flow batteries, or VRFBs, have an energy density of approximately 25 to 35 watt hours per liter. The volume calculation: to store 1,000 gigawatt hours or 109 kilowatt hours. Is that right? Total electrolyte needed. At an average of 30 watt hours per liter, you need roughly 33.3 billion liters of fluid. Total volume in cubic meters: 33,333,333 meters cubed, or 33.3 million cubic meters. Physical footprint: to visualize this lake, we can assume a dual reservoir system, analyte and catholyte. Surface area: if the lake is 10 meters or 33 feet deep, it would cover roughly 3.3 square kilometers or about 820 acres. This is roughly the size of Central Park in New York City. The caldera design: if using a natural caldera with a depth of 50 meters, the diameter would only need to be about 920 meters, or roughly 0.5 or half a mile wide, 0.5 miles wide or half a mile wide. Comparison table: storage mediums. We have features such as fire risk, lifespan, scale limit, and environmental hazards. For fire risk, the lithium-ion megapack would be extremely high thermal runaway. The Leviathan PEP with vanadium would be non-flammable and aqueous. Lifespan for a lithium-ion megapack is 10 to 15 years. For a Leviathan PEP using vanadium, it would be 25 plus years with indefinite fluid life. For a lithium-ion megapack, the scale limit is small or medium or modular, and the Leviathan PEP with vanadium, the scale limit for this would be planetary or lake or caldera scale. The environmental hazards for lithium-ion megapacks is it is toxic smoke if burned, and for a Leviathan PEP or Project Caldera PEP with vanadium, it would be the environmental hazard would be acidic groundwater risk. Creating vanadium lab versus nature. Filling a lake or caldera with vanadium represents a shift from traditional mining to planetary-scale material management. To achieve the Leviathan concept, we have to look beyond standard laboratory synthesis and current market logistics. Technically, you cannot create vanadium in a lab in the sense of synthesizing a new element from scratch, which would require a particle accelerator or nuclear reactor to fuse lighter elements. Vanadium is a primordial element. It was forged in the hearts of dying stars, or supernovae. The cost of lab grown vanadium. What scientists do in labs is refine or synthesize compounds like vanadium pentoxide from raw ores of industrial waste. Commercial cost: mined vanadium pentoxide, or V2O5, is currently priced between $9,000 and $13,000 per metric ton, roughly $5 to $6 per pound. Lab grade cost: if you require 99.99% ultra high purity for a lab experiment, the price can skyrocket to $500 per kilogram due to the intense energy required for electron beam melt refining. For Caldera, using lab grade purity would bankrupt a nation. They're probably the natural. We're going to go the natural route. The Leviathan project would use technical grade or 98% purity, which is significantly cheaper. Mining enough for Caldera, the Leviathan supply chain. Current global production is roughly 100,000 metric tons per year. A medium-sized caldera could hold millions of tons of electrolyte. To fill it, you couldn't rely on traditional mines. The waste-to-energy strategy: instead of digging new holes, Leviathan would harvest vanadium from existing industrial byproducts. Steel slag: 88% of current vanadium comes from processing iron ore. We would need to tap the global steel industry's waste streams entirely. Petroleum fly ash: vanadium naturally concentrates in heavy crude oil. When oil is burned in power plants, the soot, or fly ash, is rich in vanadium. We would essentially be mining the residue of the 20th century's fossil fuel use. Oceanic mining: seawater contains trace amounts of vanadium. While the concentration is low, 0.001 parts per million, the total volume in the ocean is billions of tons. We can use that. A Leviathan company might deploy giant ion exchange membranes in ocean currents to sift the metal out over decades. Optimal design for the oceanic sifters: mining the ocean for vanadium is necessary because terrestrial reserves are too small for Leviathan scale projects. Seawater contains vanadium at a concentration of approximately 1.8 micrograms per liter. To fill our 1,000 gigawatt hour lake, we need to process trillions of tons of water. The C-VIN current design: the most energy efficient design isn't a pump based factory, but a passive orbital current driven harvester. Macrostructure: the Kelp-Sifter. Imagine long synthetic kelp forests anchored to the seafloor in high current areas like the Gulf Stream. These fronds are made of amidoxime functionalized polymers, or covalent organic frameworks, or COFs, specifically tuned to bind with vanadate ions. Vanadate ions, H2VO4 negative. Ion selective membranes: the leaves of the sifter use nanofluidic ion exchange membranes. These membranes use sub-nanometer channels that utilize surface charge density to repel common salt ions, Na plus or Cl negative, while trapping the heavier transition metal ions like vanadium. The post-harvest cycle: absorption phase, absorption phase. The sifters sit in the current for 30 to 60 days, naturally accumulating vanadium. Automated stripping: a robotic harvester crawler traverses the tethers, spraying a mild alkaline wash like sodium hydroxide over the fronds. This releases the vanadium into a concentrated collector tank without moving the sifter. The vanadium harvest logistics: the metric, there's metrics and then requirements for 1,000 gigawatt hour refinery or caldera. Pure vanadium metal would require about 20 million metric tons of fluid. Seawater to process would be about 11 quadrillion liters, and sifter surface area would be about 500 square kilometers of membrane. The reality check: harvesting this much from the ocean would take decades. To speed this up, the Leviathan company would likely use electrochemical ocean mining, where a low voltage electrical charge is run through the sifter to actively pull ions toward the membrane, increasing the harvest rate by 10 times at the cost of some energy. Leviathan oceanic harvest. Environmental impact analysis. Removing tons of vanadium from the ocean current, like the Gulf Stream or the Kuroshio, would be one of the largest geoengineering projects in history. While vanadium is a trace element, its removal at scale triggers a domino effect on marine chemistry and biology. Disruption of marine micronutrient cycles. Vanadium is not just floating metal, it's a bioactive element. Enzymatic role. Certain marine algae and nitrogen-fixing bacteria like azotobacter, it's like the scientific name, use vanadium-dependent enzymes, vanadium nitrogenase, to convert nitrogen into a usable form. The bycatch problem, chemical co-extraction. Ocean sifters are rarely 100% selective. Even the most advanced covalent organic frameworks, or COFs, will accidentally trap other elements. Trace metal depletion. Along with vanadium, the sifters would likely harvest molybdenum, iron, and zinc. Chemical imbalance. Removing these essential materials alongside vanadium would starve the ocean current of the vitamins required for coral reef health and seashell formation or calcification. Physical impact, flow alteration, and habitat collision. A sifter field large enough to feed a 1,000 gigawatt hour lake would need to cover roughly 500 to 1,000 square kilometers of open ocean. There's plenty of ocean floor. We can do that, even without harming the environment. Current drag. The physical fronds of the sifter create drag. At scale, this could slightly slow the current's velocity or deflect its path, potentially altering coastal climates. For example, if the Gulf Stream slows, northern Europe gets significantly colder. Megafauna entanglement. While designed for ions, the sheer intensity of the synthetic kelp would pose massive entanglement risk for migrating whales, sea turtles, and large sharks. Maybe. The impact: stripping vanadium from a current could create a biological desert downstream. If the bacteria cannot fix nitrogen, the primary productivity, phytoplankton, collapses, leading to a total failure in the local food web, from krill to apex predators like tuna and whales. Biodiversity: high severity, potential collapse of nitrogen fixing bacteria. The duration would be permanent during operation. For climate, this would be low to moderate severity, pertaining to minor, or it would include minor current slowing. Duration, this would probably last centuries. Or the effect would last for centuries. Toxicity: moderate severity, chemical wash leaks. The duration would be localized and short term. Operational pollution, the leachate risk. To harvest the vanadium from the sifters, the sifter robots must use chemical washes such as that are acidic or alkaline. Micro leaks: even a 0.1% leak rate during the stripping process would release concentrated industrial chemicals directly into the pristine current. Microplastic shedding: constant buffeting by ocean waves could cause the polymer fronds to break down over time, introducing trillions of tons of microplastics into the very current we are trying to harvest. Mitigation strategies: the green Leviathan approach. To make this concept viable without destroying the ocean, we would need to implement rotational harvesting. Never harvest more than 10% of the available vanadium in a single current parcel to allow for downstream dilution. Artificial upwelling. Use the waste heat from the battery lake to pump nutrient-rich deep water to the surface, replenishing the current after it passes through the sifters. All right, biosifters. Instead of plastic fronds, genetically engineer kelp to hyperaccumulate vanadium in its tissues, which is then mowed and processed on land. The zero waste economics. We have outputs, use case, and value to Leviathan. The For purified electrolytes, this would fill the PEP lake and be the primary product. Biochar would be sold to agriculture for carbon sequestration, and it would be utilized as secondary revenue. Excess heat would be used for desalination of seawater for local freshwater, and the value to Leviathan would be goodwill for the local community. Recovered salt could be sold for industrial use, and it could be valuable in the sense of it could be used as it could reduce waste or result in waste reduction. The Bio-Sifter, genetically engineered kelp. Nature already has a patent on vanadium extraction. Certain marine organisms, specifically ascidians or sea squirts and brown algae or kelp, are natural hyperaccumulators. They use vanabins or vanadium binding proteins to pull metal from seawater, concentrating it up to 10 million times the level found in the surrounding water. The genetic blueprint: to create a Leviathan biosifter, we would engineer a fast growing kelp species like Laminara japonica with the following modifications: overexpression of VHPOs. We would amplify the genes for vanadium dependent haloperoxidases, which use vanadium as a catalyst. Transgenic vanabin integration. By splicing genes from sea squirts into the kelp's cell walls, the kelp would act as a living magnet for vanadium ions, or H2VO4 negative. Harvesting. Instead of complex chemical robots, you would simply mow the top 10% of the kelp forest every month. The harvested kelp is dried and burned or digested, leaving behind a vanadium-rich ash that is easily refined. Technical blueprint: the Aegis class sifter unit. This is the individual modular unit of the biosifter forest. It is designed to be autonomous, durable, and easily replaceable. The foundation: the submersible anchor, a heavy concrete or wheel-weighted sorry, a heavy concrete or steel-weighted base that sits on the continental shelf. It contains the pulsed induction collector, which gathers the vanadium-rich organic material harvested by the drones. The core, or bioreactor column, a vertical 30-meter tube made of reinforced transparent polymer. It houses the primary mother culture of the genetically modified kelp, protected from predators. The fronds, external growth ribbons. These are the GM kelp ribbons that extend up to 100 meters into the current. They are engineered with high tensile cellulose to prevent breaking during storms. The grazer drone is a small solar-powered or current-powered robotic crawler that lives on the central column. Every 14 days, it crawls up the fronds, shaving off the outer layer of vanadium-saturated tissue and depositing it into the collector at the base. Comparison of biosifting versus chemical sifting. The efficiency, for chemical sifters, the efficiency is high and immediate. For chemical sifters, which are synthetic, the ecological cost would be high, which would include microplastics or leaks. The political ease would be industrial or regulated, and maintenance would be high, including robotic repairs. For biosifters or GM kelp, the efficiency would be moderate or growth dependent. The ecological cost would be low, carbon sequestering. Political ease would be controversial, which would be particularly pertain to GMOs or ecology. And for biosifters or GM kelp, the maintenance would be low. They would be self replicating. The biosifter is the more sustainable long term play. It turns the battery into a carbon negative project. The kelp sucks CO2 out of the air while it sucks vanadium out of the water. Leviathan ecosystem. The Aegis sifters, the function of the Aegis sifters would be to extract vanadium from seawater using GM kelp, and the risk level would be low. It would only affect local ecology. The function of the refining plant would be to process kelp into high purity electrolytes. The risk level would be moderate, potentially resulting in chemical spills. The PEP lake would function to store 1,000 gigawatt hours of grid scale energy, and the risk level would be high, potentially resulting in geological failure. Security AI would function to manage the dead man switches and safety. The risk level would be high. This would lean more towards involving cyber warfare. Substitutes, alternatives to vanadium. If vanadium becomes too expensive or rare, the vanadium supply crunch, the Leviathan PEP could switch to other redox flow chemistries. Substitutes include iron chromium or FeCr. Pro of this is that it's extremely cheap and abundant. It's an abundant material, abundant in materials. A con would be cross contamination of fluids degrades the battery permanently. So cross contamination of fluids could degrade the battery permanently using iron chromium. Zinc bromine or ZNBr. Pro would be high energy density, very common, and they're very common elements. And con, bromine is highly toxic and volatile. Zinc can grow dendrites or spikes that puncture membranes. Ooh. Organic molecules or quinones. Pro can be grown from rhubarb or synthesized from coal or oil. It is zero metal, and zero metal mining is required or needed. Con, molecules break down over time and have a shorter lifespan than vanadium. All iron flow. A pro of this would be iron is that iron is the most abundant metal on Earth and is non-toxic. Con, has lower efficiency and is prone to hydrogen evolution or gas buildup. The winner substitute, organic flow. For a truly sustainable Leviathan, organic redox flow is the holy grail. Instead of mining metals, you would use massive chemical plants to synthesize carbon-based molecules like anthraquinones. If the lake leaks, it's essentially just organic tea rather than a heavy metal disaster. Solid. The refinery and power plant. The refining plant for the Leviathan project is where the living battery, the GM kelp, is transformed into the industrial grade electrolyte needed to power the grid. This facility is a closed loop biorefinery designed to be carbon negative and zero waste. Instead of the traditional smelting, we use a hydrometallurgical approach, which is more energy efficient and safer for the environment. The refining process from kelp to volts. Step 1, carbonization and ashing. The harvested kelp is first dried using waste heat from the refinery's own power plant. It is then placed in an oxygen-free pyrolysis chamber. The result, the kelp is reduced to a biochar, which can then be sold as soil fertilizer, soil fertilizer, and a concentrated mineral ash. This ash contains the vanadium the kelp sucked from the ocean. Step 2, acidic leaching, the dissolution. The ash is moved into large lined vats containing a 5% sulfuric acid or H2SO4 solution. The reaction, the acid dissolves the vanadium out of the ash, creating a blue liquid known as vanadilyl sulfate or VOSO4. Purity control, advanced filters and centrifugal separators remove impurities like salt, magnesium, and calcium that the kelp also absorbed. Step 3, solvent extraction, the polishing. To get the 99% purity required for the PEP, the liquid undergoes liquid-liquid extraction. A specialized organic solvent like P2O4 or Cyanex is mixed with the acid. The vanadium jumps into the organic solvent, leaving all other minerals behind. It is then stripped back into a fresh acid stream, resulting in ultra pure electrolyte. Step 4, electrolytic balancing. The final step happens in an electrolytic cell. The vanadium is balanced into a V3.5 plus state, a perfect 50-50 mix of V3 plus and V4 plus. This master liquid is what finally gets pumped into the Leviathan lake. Suggestions for site selection. While calderas like La Garita in Colorado offer the volume for a lake, they are often located in mountainous regions with higher seismic activity or complex groundwater networks. For your first generation PEPs, it is recommended the salt domes of the Gulf Coast are recommended. The self-healing nature of salt provides a margin of safety that hard rock cannot match during the experimental phase. Choosing the right location for Leviathan Potential Energy Pool, or PEP, requires a rare combination: tectonic dead zones to prevent cracks, impermeable rock or salt formations to contain the acid, and access to oceanic currents for your biosifters. Based on geological stability, existing salt dome infrastructure, and distance from major fault lines, here are the top 3 sites for your first terawatt scale energy reservoirs. The Gulf Coast salt domes in Texas or Louisiana, USA. This is the golden standard for large scale liquid storage. The region sits on a massive, stable shelf with thousands of naturally occurring salt diapirs deposits. Geology, salt domes or halite, halite. Salt is ideal for acid storage because it is virtually impermeable and self-healing. If a micro crack formed, the salt plastically deforms to seal it. Infrastructure, this is where the U.S. Strategic Petroleum Reserve is located. We already have the technology to leach out caverns that are 2,000 feet tall. Strategic advantage, immediate access to the Gulf Stream for your biosifters. The refining plant could be built directly over the salt domes, creating a pit-to-plug efficiency. The Gawler Craton in South Australia. Australia is one of the most tectonically stable continents on Earth, and the Gawler Craton is its frozen heart, a massive block of ancient, rigid, crystalline rock that hasn't moved significantly in millions of years. Geology, crystalline bedrock or granite or gneiss. Unlike salt, this requires mechanical mining, but the stability is unparalleled. It is essentially a planetary vault. Logistics, the proximity to the Southern Ocean provides a cold, nutrient-rich current for high-density vanadium harvesting. Strategic advantage, low population density. If a Tier 3 event, a breach occurred, the exclusion zone would affect very few people, and the alkaline-rich desert soil could act as a natural buffer to neutralize acid spills. The Baltic Shield, Sweden, Norway, and Finland. The Fennoscandian Shield is a massive piece of Earth's crust that is exceptionally thick and stable. It has survived multiple ice ages without cracking. Geology, hard rock, igneous rock. Scandinavian countries already lead the world in underground water-sealed oil storage. Cool. Logistics, access to the North Atlantic current. While colder, this current is a conveyor belt of trace minerals. Strategic advantage, political stability. Building a Leviathan or Caldera, building Project Caldera here requires a 50-year commitment. The Nordic countries' high global risk safety ratings make this the safest place for the Security AI and the Planetary Energy Accord headquarters. Comparative stability analysis, the 2026 forecast. Gulf Coast, the stability rating is 85 out of 100. The containment method used would be salt caverns, which could self-heal, and sifter access would be the high Gulf Stream. Sifter access would be high, utilizing the Gulf Stream. For Gawler Creighton, or Gawler Creton, Gawler Creighton, stability rating is 98 out of 100. The containment method would be lined hard rock caverns, and sifter access would be moderate using the Southern Ocean. For the Baltic Shield, the stability rating for this location is 92 out of 100. The containment method would be water sealed or lined rock. Sifter access would be high using the North Atlantic. To formalize the Leviathan architecture, we must look upward and outward. A project of this magnitude cannot be managed by humans with clipboards. It requires an orbital overseer and a centralized brain capable of balancing the energy needs of a continent. With the addition of the satellite and hub infrastructure, the safety and security score of the project jumps significantly. It is now a closed-loop, self-protecting system. The quote-unquote Argus 5 monitoring satellite constellation. The Argus 5 is a dedicated constellation of 3 geostationary or GEO geosatellites and a swarm of low Earth orbit or LEO sentinel units. Key orbital technologies. Hyperspectral chemical sensing. The satellites use Fourier transform infrared or FTIR spectrometry to see the chemical signature of vanadium or sulfuric acid. If a microleak occurs, the satellite detects the specific gas plume or ground tint change before sensors on the ground even trigger. SAR, synthetic aperture radar topography. Unlike optical cameras, SAR can see through clouds and darkness. It monitors the caldera's structural integrity with millimeter precision, detecting subsidence or ground sinking that might indicate a subsurface crack in the bedrock. Quantum key distribution, or QKD. To prevent cyber attacks, the satellites provide a space-based quantum cryptography link. The encryption keys for the security AI are beamed down via lasers, making it physically impossible for an earthbound hacker to intercept or spoof the control commands. The Nexus Dispatch Hub. The Nexus is the nerve center where the PEP meets the world. Imagine a facility that looks like a NASA mission control, but for the Earth's energy heartbeat. Anatomy of the hub. The hologrid visualization. A massive 3D projection of the continental grid. Dispatchers don't look at numbers, they see energy weather, flowing rivers of power. They can see a storm coming in the Atlantic and preload the PEP's pumps to catch the incoming wind surge. The transnational load balancer. The hub coordinates with regional transmission organizations, or RTOs. Using AI-assisted topology optimization, the Nexus can reroute power across 15 different states or nations in milliseconds to prevent a cascade failure. The BioLink terminal. A dedicated wing of the hub monitors the Bio-Sifter forests. It tracks kelp growth rates, vanadium uptake, and harvester drone health, ensuring the supply chain of raw metal never stops. The Guardian protocol for satellite hub integration. In the event of a seismic event, the satellite will detect 2 millimeter shifts in caldera walls via SAR. For the dispatch hub, the action taken would be to immediately trigger safe state pumps and um, drains affected in the zone. For cyber intrusions, the satellite would detect unauthorized signals from ground stations, and then the dispatch hub would utilize AI air gaps in the site and would switch to satellite only laser control. For peak surges, the satellite would predict 20% increases in heat, up to 20% increases, or would that be the baseline? Would predict 20% increases in heat wave demand, and the dispatch hub would sell 500 gigawatt hours to the grid at maximum arbitrage profit. Geopolitical implications, the terawatt monopoly. This is one to consider as well. The single company or nation controlling 1,000 gigawatt hours or 1 terawatt hour of stored energy would hold the master key to the global economy. This is no longer just a battery, it's a geopolitical weapon. Don't want that. So, safeguards, contingencies. We'll come back to that. Energy blackmail. If a nation relies on Leviathan or Project Caldera for its grid stability, the company could theoretically hold that nation hostage. Ugh. The slow drain threat. By slightly reducing output during peak hours, the company could artificially spike energy prices, effectively taxing a whole continent's industry. Strategic sovereignty. To prevent this, nations would likely pass energy sovereignty laws requiring the 1,000 gigawatt hour lake to be physically located within their borders and managed by a state controlled entity, similar to how strategic oil reserves are managed today. The OPEC of storage, or OPEC as storage. If multiple Leviathan sites are built, we might see the rise of OSEC, or Organization of Storage Exporting Countries. Instead of controlling the source of energy, oil, sun, or wind, they control the buffer. This shifts global power from who has the most sun to who has the best geology or ocean currents to store it. The political risk of centralization. The first risk is the single point of failure. A 1,000 gigawatt hour lake is a massive target. A single successful sabotage or technical failure could plunge an entire hemisphere into darkness for weeks. The second risk is nationalization. If the Leviathan company becomes too powerful, a host government is likely to nationalize the assets, leading to international legal battles and potential trade wars. Environmental litigation. Bio-Sifters could be seen as genetic pollution. Anti-GMO movements might target the kelp forests, leading to massive legal delays in construction. The Leviathan concept is technically possible if we prioritize genetics or biosifters over mechanical mining. However, the sheer concentration of energy and acid makes it a high risk, high reward venture. It would require a global treaty, a planetary energy accord to ensure that no single entity uses the power to dominate others. The Planetary Energy Accord, or PEA, or P, little P in a pod. To prevent the Leviathan company from becoming a global tyrant, a treaty must be signed. This prevents energy storage from being used as a weapon of war. Article 1, the Neutral Ground Principle. Leviathan PEPs shall be designated as international sovereign zones similar to the International Space Station. No single nation may station military forces within 50 kilometers of a PEP site. Article 2, mandatory storage caps. To prevent a terawatt monopoly, no single entity or nation may control more than 15% of the total global storage capacity. This forces the development of multiple competing PEPs across different continents. For example, the Icelandic PEP, the Andes PEP, and the Australian PEP. Article 3, the algorithm audit. The security AI source code must be open source and audited annually by a multinational council of mathematicians and ethicists to ensure no backdoors or bias have been programmed into the grid management. Article 4, ecological accountability. If a Bio-Sifter forest causes a collapse in local biodiversity, the operator is liable for ecological reparations funded by an energy tax collected on every megawatt hour stored. So, we go on to say, please provide detailed feedback for the following. Recapping what we've covered so far, what do you think about the idea overall? This idea is a planetary scale redox ecosystem. It's brilliant because it doesn't just treat the battery as a box you buy, it treats energy storage as a biological and geological cycle. By using the ocean as a mine and calderas as containers, you are essentially hacking the Earth's natural geography to serve as a power grid. Do you have any suggestions for additions, subtractions, and modifications? First up, we have additions. The thermal battery layer. Vanadium flow batteries generate heat during the charge or discharge cycle. You should add a secondary steam loop. So we need to add a secondary steam loop. The heat from the lake could drive turbines or provide industrial heating for the refining plant, raising the round trip efficiency from about 75% to over 90%. Kinetic surface shielding. To protect against sabotage, the lake's surface should be covered by hexagonal floating solar arrays. This obscures the lake from satellite view, prevents evaporation, and generates the power needed to run the refinery. Subtractions, the space-based PEP. I would actually suggest subtracting the orbital acid pool. The gravity well tax, the energy cost to move millions of tons of acid into space is too high, currently at least. If you want space-based energy, use orbital mirrors to beam microwave energy down to the terrestrial PEP instead. Modifications, decentralized lakes. Instead of one massive 1,000 gigawatt hour caldera, consider a chain of lakes about 10 times 100 gigawatt. So 10 100 gigawatt hour lakes or 110 gigawatt hour lakes, something in between. This mitigates the single point of failure risk. If one lake is sabotaged, the continent as a whole doesn't go dark. Do you think this concept is viable? Viability analysis? Viability analysis. Is it viable? Technically, yes. We have the chemistry, such as vanadium redox, and the genetic tools, CRISPR for Kelp, to do this. Economically, however, currently, no. The upfront cost to build the first refinery and sifter forest would be trillions. It only becomes viable when the cost of carbon or energy scarcity exceeds the cost of this mega infrastructure. Geologically, it is highly viable. Earth has plenty of stable basaltic basins and extinct calderas that can hold these volumes safely. On a scale from 1 to 100, what would your overall rating of this concept be? Overall rating, currently, until there's further edits, currently 84 out of 100, so B minus. Innovation, 98 out of 100. Scalability, 95 out of 100. Safety and risk, 45 out of 100. This drags the score down. A breach is a level extinction event for local ecosystems. Whew. Economic realism, 60 out of 100. Again, not currently economically feasible, but maybe one day. Start astro mining. Again, using Leviathan. What factors jeopardize this concept's feasibility? The vanadium bottleneck. Even with biosifters, the sheer mass of metal required is staggering. If the GM kelp doesn't perform at the projected 10 million times concentration rate, the project stalls. Material degradation. Concentrated sulfuric acid is hungry. Over 20 to 30 years, it can find micro fissures in even the best ceramic liners. The maintenance cost of a lake-sized liner would eventually eat the profits. Ecological blowback. If the GM kelp escapes the sifter forests and begins outcompeting natural kelp globally, You solve the energy crisis, but potentially collapse the oceanic oxygen cycle. Sorry. Political instability, as we discussed, the terawatt monopoly. If a project like this is seen as a death star of energy, rival nations might strike it preemptively to prevent a shift in the global balance of power. Prospective partnerships. Who will I need to work with to make this concept work? Including government, officials, legislators, regulators, etc., resource partners, stockholders and investors, third party services and business affiliates, and etc. To bring the Leviathan or Project Caldera from a blueprint to a functional reality, we will need to assemble a coalition of the unprecedented. Because this project touches on deep ocean and high atmospheric satellites and the internal geology of nations, our partnership network must be multidisciplinary and global. Government and regulatory partners. We aren't just building a battery, we're modifying the planetary commons. These agencies hold the go or no go power. Maritime and oceanic authorities in the US, the National Oceanic and Atmospheric Administration, or NOAA, and the EPA under the Marine Protection, Research, and Sanctuaries Act are your primary gatekeepers for the biosifters. Internationally, you must work with the International Seabed Authority, or ISA, energy regulators, agencies like the Federal Energy Regulatory Commission, or FERC, and DOE, Department of Energy, will oversee the grid interconnection and strategic storage designations. Environmental and security agencies. You will need clearance from the Bureau of Safety and Environmental Enforcement, or BSEE, or BC, for the Caldera lining, and potentially the Department of Defense, or DoD, due to the project's status as critical national infrastructure. Resource and supply chain partners. The blood and muscle of Leviathan come from these industrial giants. Vanadium and mineral producers. You need established mining partners like Largo Incorporated or Vanadium Corp to provide the initial seed electrolyte while your biosifters scale up. Biotech labs, partnerships with firms specializing in marine CRISPR applications. For example, synthetic biology startups focused on carbon sequestration to develop and maintain the GM Kelp strains. Industrial chemical suppliers, giants like BASF or Dow for the massive volumes of high purity sulfuric acid and specialized fluoropolymer liners, or PTFE. Stockholders and strategic investors. At a $380 billion capex, you need patient capital, investors who value long term stability over 90-day returns. Sovereign wealth funds, organizations like Norway's NBIM or the UAE's Masdar, are ideal as they invest in 50-year cycles and value energy security. Infrastructure investment firms, groups like Excelsior Energy Capital or Gore Street Capital, which specifically focus on large-scale battery and grid assets. Green tech philanthropy, the Bezos Earth Fund or the Global Energy Alliance for People and Planet, or GEAPP, could provide the first loss capital or grants needed for the Bio-Sifter R&D phase. Third-party services and business affiliates. These are the service robots and legal shields of the operation. Sorry. Okay. Third-party services and business affiliates. These are the service robots and legal shields of the operation. Maritime law firms. The specific role of maritime law firms would be to navigate the BBNJ Treaty and oceanic liability. An example entity from 2026, or the 2026 landscape, would be Holland and Knight or Van Ness Feldman. Satellite operators, they would provide the Argus 5 monitoring and QKD links. For example, SpaceX through Starlink or Planet Labs. For AI and cybersecurity, these would be used to develop the air-gapped security AI and EVM. For example, an example entity would be either Palantir or Microsoft through the Azure government. Insurance underwriters would create the parametric, seismic, and biorisk policies. Example entities include the Swiss Re or the Lloyds of London. Lloyd, the Lloyds of London. Summary of the partnership hierarchy. Anchor partners provide the vision and the first $10 billion. These would probably be philanthropists or sovereigns. Execution partners provide the how. Engineering firms like Bechtel, and Siemens Energy. Regulatory partners provide the permission. These would include the UN or national governments. Final assessment of partnerships. The project's greatest risk is not technical, it is diplomatic. If we fail to get the high seas nations on board with our Bio-Sifters, the project will be tied up in international courts for decades. Our most important hire will be our chief regulatory officer. Resources and materials required. Ooh. The electrolyte. Chemical and mineral requirements. The liquid fuel for the PEP is the most resource-intensive component. At 1,000 gigawatt hours, the volume of electrolyte is roughly 33.3 billion liters. We have different resources here. Vanadium pentoxide, or V2O5, the quantity required would be about 20 million metric tons, and the primary source would be biosifters, steel slag, and petroleum fly ash. For sulfuric acid, or H2SO4, we would require about 100 million metric tons. Primary source would be sulfur from oil or gas refining and smelter byproduct. For ultra pure water, we would require about 25 billion liters. The primary source would be on-site desalination or reverse osmosis. And for stabilizing additives, we would require about 500,000 metric tons or 500,000 metric tons. And the primary source would be phosphoric acid and ammonium compounds. For infrastructure, regarding geological and structural materials, containing a caldera-sized lake of acid requires specialized materials that won't dissolve over decades. The primary containment liners are high-density polyethylene, or HDPE, miles of 3 millimeter thick sheets for the initial barrier. Fluoropolymers, or PTFE/PVDF, specialized Teflon-style coatings for the high heat pump junctions. Acid-resistant concrete, reinforced with basalt fiber rather than steel to prevent corrosion. Secondary containment, for which would be geological. Secondary geological containment. Bentonite clay. Thousands of tons of self-sealing clay used as a buffer between the liner and the bedrock. Sodium smectite, used to line salt domes or granite caverns to create a natural ion trap in case of leaks. The Bio-Sifter fleet, biology or biotechnology requirements. To harvest the vanadium, we would need massive synthetic ecology, genetic engineering lab equipment, CRISPR-Cas9 kits for precise editing of kelp DNA, digital PCR, DPCR machines to monitor the concentration of vanadium binding genes in the kelp population, environmental DNA or eDNA sensors to track with health of the Bio-Sifter forest and detect escaped genetic material, marine hardware, modular anchor bases, high weight concrete blocks with anti-biofouling coatings, autonomous underwater vehicles or AUVs, the grazer drones that shave the kelp would be an example of this. Autonomous underwater vehicles, AUVs, satellite linked buoys for real time monitoring of ocean currents and vanadium uptake rates. The security AI and control systems. The brain of Leviathan requires high performance, resilient computing. Air gapped server arrays, physically isolated from the internet to prevent remote hacking. Haptic security suits for all on site personnel equipped with biometrics, heart rate, or gait analysis. Distributed acoustic sensing, or DAS, miles of fiber optic cable buried around the site to detect unauthorized drilling or tunneling. Redundant power electronics, carbon based electrodes such as graphite felt, and bipolar plates like graphite with 10% PTFE to handle the 1000 gigawatt hour transfer. Budgeting and financial strategy. Building a 1000 gigawatt hour Leviathan or Project Caldera is less like building a power plant and more like building the Panama Canal. It is a generational infrastructure project. As of 2026, the economics of energy storage have shifted dramatically, with the utility scale battery costs dropping to approximately $125 per kilowatt hour for lithium based systems. However, because Leviathan uses vanadium redox flow and Bio-Sifters, the financial model is unique. It trades higher upfront capital expenditure, or CAPEX, for a much lower operational expenditure, OPEX, and a nearly infinite lifespan. Summary of costs and feasibility. Building a single 1000 gigawatt hour potential energy pool, or PEP, would effectively consume 200 years of current global vanadium production. This is why the biosifters and industrial waste harvesting are not optional. They are the only way to obtain the materials without crashing the global market. Total project estimate in phase one, capital expenditure, or CAPEX, $400 to $600 billion, estimated based on 2026 flow battery costs of about $420 per kilowatt hour. Operational timeline, 15 to 20 years to harvest enough material to reach full capacity. The capital expenditure, or CAPEX, the setup cost for the electrolytes, the blood of the operation. The estimated cost for a 1000 gigawatt hour facility would be covers the sulfuric acid and the initial vanadium seed load. At current 2026 technical grade prices, this is our largest single cost. For a geological excavation, this would cost roughly $40 to $60 billion. Based on salt dome leaching or hard rock mining at 33 million cubic meter scale. Marine biosifter fleet would cost $80 to $100 billion. 1,000 square kilometers of Aegis units, including the initial GM kelp seeding and AUV harvester drones. Power electronics and grid, this would be $50 to $70 billion. Heavy duty HVDC interconnects, stacks, and the air gapped security AI heavy duty HVDC interconnects, stacks, and the air gapped security AI core. Total initial capital expenditure, or CAPEX, would be $270 to $380 billion, roughly the cost of 10 to 15 nuclear power plants. Okay. Wow. I see the issue there. That's fine. We can still work things out. Work out the kinks. Still tweaking it. Operational expenditure, OPEX, the maintenance cost. Unlike lithium batteries, which must be replaced every 10 to 15 years, a massive recurring CAPEX The Leviathan's electrolyte is immortal. Standard maintenance, 2% of capex per year, about $6 to $8 billion a year. This covers drone repairs, pump maintenance, and security personnel. The vanadium dividend, because your biosifters are constantly pulling vanadium from the ocean, you eventually harvest more than you need. You can sell excess vanadium to the aerospace or steel industries, potentially turning the OPEX into a profit center after year 15. Financial strategy and funding models. A project this size cannot be funded by a single company. It requires a hybrid sovereign private model. The sovereign energy bond, the 50-year strategy. Governments issue Leviathan bonds with a 50-year maturity. These are seen as safe haven investments for pension funds similar to treasury bills because the asset, the energy and the vanadium is physically tangible and doesn't degrade. The storage as a service or SaaS revenue model. Leviathan doesn't sell electricity, it charges for capacity. The insurance fee. Major tech companies, Google, Amazon, etc., pay a monthly retainer to ensure their data centers have priority access to the PEP during a grid failure. The time shift arbitrage. The company buys solar energy at noon when it's nearly $0 and sells it back at 7 p.m. when prices are at their peak. Economic viability, the LCOS, or levelized cost of storage. The true measure of a battery is the levelized cost of storage, or LCOS, the cost to move 1 megawatt hour from charging to discharging over the project's life. Lithium-ion in 2026 was this cost about $65 million per kilowatt hour. Or hold on, sorry, back up. This cost about $65 per megawatt hour, assuming a 20-year life. And for Leviathan PEB, the projected cost would be about $35 to $45 per megawatt hour. The higher initial cost is offset by the fact that the lake doesn't need to be replaced. Over 50 years, Leviathan is the cheapest energy storage method ever devised. Risks to the budget. Vanadium volatility. If a cheaper substitute, like organic flow, is invented before phase 2 is finished, our vanadium reserve could drop in value. Marine liability. If a Bio-Sifter forest is destroyed by a superstorm, the insurance premiums could skyrocket. Regulatory tax. If the Planetary Energy Accord imposes high taxes on mega infrastructure, the ROI, the return on investment timeline, could push from 12 years out to 25 years. To finalize the financial and risk architecture for Leviathan, we must treat it as a massive revenue engine that pays for its own security and ecological stewardship. By 2026, the global energy storage market is reaching a fever pitch with over 150 gigawatt scale projects under development, making the timing for a 1,000 gigawatt hour Leviathan or Project Caldera both audacious and economically strategic. Just quick edit real quick. Okay. Annual revenue simulation, the terawatt harvest. A 1,000 gigawatt hour PEP doesn't just store energy, it optimizes the entire grid's value. In 2026, storage projects are seeing revenues between $45 and $320 per kilowatt hour a year, depending on the market and duration. Revenue streams would include energy arbitrage, which would generate an estimated annual revenue of $12 to $18 billion. Energy arbitrage would include buying excess solar or wind at about $0 per megawatt hour and selling at a peak for about 150 plus megawatt hours, $150 plus per megawatt hour. Ancillary services would generate an estimated annual revenue of $4 to $6 billion. Frequency regulation and voltage support. As spinning reserves, coal and gas retire, Leviathan becomes the grid's primary stabilizer. Capacity payments would be worth an estimated annual revenue of $3 to $5 billion. Retainers paid by government or utilities just to ensure the energy is available for emergencies. Cool. And then vanadium sales. This would generate an estimated annual revenue of $1 to $2 billion. Revenue from the Bio-Sifter surplus sold to the steel and aerospace industries. Total annual revenue would be approximately $20 to $31 billion per year. This would be the annual gross revenue. Net profit margin, given the low operational expenses or OPEX of flow batteries, which have no chemical degradation, we project that a 25 to 30% net margin. We project a 25 to 30% net margin, allowing for CAPEX payback in roughly 12 to 15 years. Capital expenditure payback. Cool. ROI. Love it. Insurance and risk management plan. Ensuring a caldera of acid and a forest of GM kelp requires a hybrid of maritime and industrial all-risk policies. The operational all-risk or OAR policy, this covers physical damage to the caldera liners or refinery. Key clause, parametric seismic trigger. If an earthquake above a 6.0 magnitude occurs within 100 kilometers, the policy pays out immediately for structural inspections before a leak even occurs. Marine bioinfrastructure insurance. Standard aquaculture insurance is insufficient for a 1,000 kilometers squared sifter forest. There we go. Risk mitigation. The Aegis sifters are insured against extreme weather events such as hurricanes or cyclones. The grazer drone coverage. Harvester drones are insured under a hull and machinery or H&M policy, similar to commercial vessels, covering collisions or mechanical failure at sea. The Environmental Catastrophe Fund. To comply with the Planetary Energy Accord, Leviathan must maintain a self-insured retention or SIR fund of must maintain a self-insured retention or SIR fund, a $10 billion liquid reserve specifically for environmental cleanup in the event of a Tier 3 breach. Financial strategy, the Green Leviathan Bond, to raise the $380 billion capital expenditure, CAPEX, we utilize blue-green transition bonds. Incentive, investors with pension funds or ESG portfolios receive a tax-exempt coupon because the project directly replaces carbon-intensive peaker plants and sequesters carbon through the kelp forest. Rating, by 2026, long-duration energy storage, or LDES, is rated as mature infrastructure, allowing for favorable interest rates, 4 to 6%, compared to high-risk tech startups. Okay. Final conclusions, the Leviathan rating. Technological viability, 90 out of 100. Chemistry is proven. Genetics is the only active frontier. Economic feasibility, 75 out of 100. This one got boosted up a little bit from 60 before. High upfront cost, but unmatched LCOS, or levelized cost of storage. Safety and security, 65 to 100. 65 out of 100. This got bumped up from, I believe it was 45 before. The acid lake remains a high consequence risk if security fails. Overall rating, 77 out of 100. A civilization-defining project with planetary hero potential. Now, for the fun part, regulatory and legal compliance. Maintaining regulatory and legal compliance for a project as massive as Leviathan or Project Caldera is as complex as the engineering itself. As of 2026, the landscape for energy storage and oceanic engineering has matured with new international treaties and domestic laws specifically targeting long duration energy storage, or LDES, and marine biodiversity. To operate legally, Leviathan must navigate three distinct regulatory tiers: industrial safety, oceanic governments, oceanic governance, and genetic compliance. Domestic energy and safety hazards. If the PEP is located within a sovereign territory like the Texas Gulf Coast, it must adhere to strict fire and chemical safety codes. NFPA 855, the 2026 update. This is the primary standard for the installation of stationary energy storage systems. While originally focused on lithium ion, the 2026 revisions include specific chapters for flow battery caverns, mandating redundant secondary containment and automated acid neutralization systems. UL 9540 and 9540A or 9540A. These certify the safety of the entire energy storage system. Leviathan must pass large scale fire testing, proving that even a catastrophic pump failure won't lead to a toxic plume event that exceeds local air quality mandates. EPA and RCRA compliance. Under the Resource Conservation and Recovery Act, RCRA, the sulfuric acid electrolyte is classified as a hazardous material. The facility must have a cradle to grave tracking system for every liter of acid used. International Oceanic Law, the BBNJ Treaty. The most significant legal hurdle for your biosifters is the High Seas Treaty, or BBNJ Agreement, which officially entered into force on January 17th, 2026. Ooh, it's relatively new. Marine Genetic Resources, or MGRs. The treaty mandates the fair and equitable sharing of benefits derived from genetic material found in international waters. Because your kelp uses genes from deep sea tunicates, Leviathan may be legally required to pay a percentage of its profits into a UN managed global biodiversity fund. Environmental Impact Assessments, or EIA. Before deploying a 1,000 kilometer squared sifter forest, the BBNJ requires an international EIA. You must prove that stripping vanadium from the current won't significantly harm the downstream marine food web. Makes sense. IMO MARPOL, or IMO Marpol Annex the Second, or Annex 2, IMO Marpol Annex 2. Your sifter maintenance vessels must comply with regulations regarding the transport of noxious liquid substances. Any accidental discharge of the cleaning agents used on the kelp fronds could result in massive international fines. Genetic and biosecurity regulations. Using genetically modified GM kelp, genetically modified GM kelp in the open ocean is legally high risk. The Cartagena Protocol on Biosafety. This international agreement governs the movement of living modified organisms, or LMOs. Leviathan must prove that the GM, or genetically modified kelp, contains a genetic kill switch, an engineered metabolic dependency that prevents the kelp from surviving if it drifts outside the designated harvest zone. National security screenings, or CFIUS. In the US, the Committee on Foreign Investment now scrutinizes large scale storage projects. If foreign entities own more than 10% stake in Leviathan, it may be designated a critical infrastructure risk subject to constant federal monitoring. Compliance checklist for Leviathan. We have different regulatory bodies here. For the UN, or ISA, the requirement would be the BBNJ treaty compliance, and this would focus on Bio-Sifter genetic sharing and EIAs. For NFPA, or UL, the requirement would be standard 855 and 9540. This would focus on fire safety and cavern containment. For the EPA and OSHA, or OSHA, The requirement would be HZMAT and RCRA. This would focus on acid handling and worker safety. For the IMO, the requirement would be MARPOL and SOLAS, or MARPOL and SOLAS. This would focus on the Sifter fleet maritime safety. In summary, for the legal buffer, to ensure long-term viability, the Leviathan company should establish a legal reserve fund to equal 5% of its annual revenue. This fund is used to navigate the evolving constitution of the oceans and to lobby for new standards that recognize the unique benefits of long-duration flow batteries over lithium-ion. Now, an update on the overall concept recap and final assessment for innovation. This is 98 out of 100, unmatched. Viability, 84 out of 100, technically ready, legally complex. And final rating, 84 out of 100. Ethical and moral arguments for and against. What are some supporting arguments that can be made to endorse this concept, and what are some rebuttals that may be proposed in opposition to this concept? The Leviathan concept is a Rorschach test for modern ethics. To some, it represents the pinnacle of human ingenuity, saving the planet. To others, it is the ultimate expression of human hubris, overstepping ecological boundaries. Drawing from the current 2026 ethical landscape regarding eco-engineering and mega batteries, or regarding geoengineering, sorry, my mouse is over that word, geoengineering and mega batteries, here is the moral breakdown of the concept. Supporting arguments: the case for planetary stewardship, the greater good utilitarian defense, climate salvation. The most powerful moral argument is that the cost of inaction far outweighs the risks of Leviathan or Project Caldera. If a 1,000 gigawatt hour battery is the only way to facilitate a 100% renewable grid and stop global boiling, then building it is a moral imperative. Decentralizing energy geopolitics. By moving away from fossil fuels, often controlled by petro-autocracies, Leviathan could democratize energy. If nations can harvest their own vanadium and store their own sun or solar power, it reduces the moral cost of energy wars. The bioregenerative loop, carbon sequestration. Unlike traditional mining, which is purely extractive, the Bio-Sifter model is regenerative. The GM, or genetically modified kelp, pulls CO2 out of the ocean while it gathers vanadium, making Leviathan a dual benefit climate solution. Restorative industry. By mining vanadium from 20th century waste, such as steel slag, and fly ash, the project cleans up historical industrial pollution, turning poison into power. Rebuttals and opposition. The case against, which would include technological hubris. The moral hazard argument, delaying real change. Critics argue that techno fixes like Leviathan provide a get-out-of-jail-free card for high-consumption lifestyles. If we believe a giant battery can save us, we may lose the political will to reduce our total energy demand or reform our economic systems. There's plenty of resources out there, man. We just got to get the resources. We don't have to just depend on Earth's resources. Ugh. It's not sustainable. We can't use Earth's resources. We're gonna run out of resources. Let's go to space, motherfuckers. God damn. Sorry. Oh man. There's all space. Let's invest more in NASA. It's SpaceX. As always, keep looking up. All right. Playing God with the oceans. Hold on. Okay. Playing God with the oceans. Releasing genetically modified organisms, the kelp, into a global current is the ultimate ethical red line. Opponents would argue that we cannot predict the butterfly effect on the marine food web. Dude, we're doing so much other shit. That's probably the least of our problems. You think that's the biggest issue? Nope. We're doing so much other things to affect our environment. That's probably the least of our concerns. Creating new life, contributing to it, or expediting adaptation and evolution, possibly. What's it called when species become new species? Or like split off? Something speciation? I don't know. It's like basically we're species, like you have one species, like say humanity, and then we're to start splitting off into multiple different types of species. Kind of like what's happened throughout millions of years of evolution. Opponents would argue that we cannot predict the butterfly effect on the marine food, blah blah blah. If the kelp outcompetes wild species, we have traded an energy crisis for an ecological collapse. Oh no. Yeah, we can monitor it. The environmental justice critique. Regional sacrifice zones. A Caldera-sized acid pool creates a sacrifice zone. While the global benefit is high, the local risk, leaks, and toxic vapors, is borne entirely by the communities living near the site, who are often marginalized groups with little say in the project's siting. The terawatt monopoly. There is a moral danger in a single corporation or state controlling a week's worth of a continent's power. Maybe. We'll split it up. We'll delegate authority out to it. We'll manage that. We're good. We can manage that. It creates an unprecedented power imbalance that could lead to energy colonialism. Wow. How much more do I have, damn? So much. You know what? Almost done. You know what? I'm just going to finish it. Skip like a minute ahead. I'll be right back. I don't feel like calling you. All right. Okay, we're back. That was about a minute, right? All right, ethical comparison matrix. So we have different ethical lenses. First ethical lens we're going to look at this through is the precautionary principle. And the supporting and endorsing arguments. We must act now because the climate threat is certain. The opposition or rebuttal argument. We must not act because the risks of genetically modified kelp or acid spills are unknown. Next, we have distributive justice. The supporting and endorsing arguments. Support and endorsement would include arguments such as it provides clean, stable energy for everyone. Opposition and rebuttals would say that it concentrates wealth and power in the hands of the Leviathan owners. Next, we have environmental ethics. Support and endorsement would include arguments such as it cleans up waste and sequesters carbon. Opposing arguments and rebuttals would mention that it transforms a natural ocean into a human-controlled artifact. Okay. Final moral standing, the lesser of two evils. In the 2026 ethical discourse, Leviathan is often viewed through the lens of emergency ethics. Most ethicists agree that while the concept has significant hubris risks, it is morally superior to the continued combustion of fossil fuels, which causes millions of respiratory deaths and systemic planetary collapse every year. The moral verdict: Leviathan is only ethical if it is transparently governed as per your planetary energy accord, and if it includes a right to restoration for any community or ecosystem impacted by its construction. The security AI code of ethics. As we approach the final architecture of the Leviathan, or Project Caldera, we must shift from the hardware and software to the heart of the project. To be successful, the system needs an ethical soul and a public identity that invites trust rather than fear. The air gap security AI isn't just a set of if and then statements. It is governed by an embedded ethics verification module, or EVM, in line with the NIST, or National Institute of Standards and Technology AI Risk Management Framework, and the OECD AI principles. The AI is programmed with hard coded constraints that override its efficiency goals. The safety first prime directives, the non maleficence override. If an action to balance the grid results in a greater than 0.01% risk of structural breach, for example, overpressurizing a pump, the AI must default to a safe state, shutting down power flow even if it causes a localized blackout. Radical transparency, the explainable AI clause. Every decision the AI makes, from micro adjusting voltage to triggering a tier 1 alarm, must be logged in a human readable audit trail. This log is mirrored to a physical, tamper proof, laser etched glass storage medium every 24 hours. Environmental equity. The AI is programmed to prioritize the stability of the local ecosystem's water table over the profitability of energy arbitrage. It monitors the Bio-Sifter health in real time and must throttle energy production if the kelp forest shows signs of thermal stress. Positive and negative impacts on society. What is the short term and long term economic impact, and what is the short term and long term environmental impact? Public relations and community engagement. If Leviathan Project, or Project Caldera, would act as a massive socioeconomic and environmental shock to the global system. Did I say if? The Leviathan Project, or Project Caldera, would act as a massive socioeconomic and environmental shock to the global system. Because of its unprecedented scale, equivalent to a strategic energy reserve for an entire continent, the impacts transition from local industrial growth to planetary scale shifts in resource management. To win over a skeptical public, even those living near a caldera-sized acid pool, Leviathan must abandon top-down corporate public relations, or PR, in favor of collaborative currents, a 2026 conflict resolution model. The radical inclusion strategy, the community hub, physical presence. Before the first liter of acid is poured, Leviathan establishes a permanent staffed information hub in the nearest town. It features digital renders and scale models to demystify the technology. The Vanadium Dividend Program. A percentage of the revenue from vanadium sales is placed into a community wealth fund. This fund is managed by local residents to pay for schools, hospitals, and infrastructure, ensuring the community sees a tangible green premium. Citizen science monitoring. Local schools and environmental groups are provided with sensors and training to conduct their own independent air and water quality tests, which are then compared against the company's official data on a public dashboard. The Leviathan brand identity. This project shouldn't be marketed as a machine, but as a protective organ for the planet. We have 3 different pillars to focus on here: safety, ecology, and future. For safety, the primary messaging would be that Project Caldera be known as the vault of the earth. Visual language be heavy stone textures, deep blues, and geometric stability. For ecology, primary messaging would be living power. For visual language, we'd use vibrant kelp greens, flowing water, and marine life imagery. And then for the future, the primary messaging to address goals pertaining to the future, this would be a 100-year legacy. Clean lines, for visual language, would be clean lines, open horizons, and images of children thriving in thriving landscapes. Okay. All right. Economic impacts. In the short term, first 1 to 5 years, positive impacts would include an infrastructure boom, trillions in capital flow into construction, trillions of dollars in capital flow into construction, metallurgy, and biotech sectors, millions of jobs in the green geoengineering field will be opened and filled. Negative impacts, supply chain distortion. The sudden demand for 20 million tons of vanadium and 100 million tons of acid spikes global prices, potentially hurting other industries like steel and aerospace. Probably temporarily. We're going to need to use that though. Long term, 10 to 50 years, energy price flatlining by removing this is a positive impact for positive. So 10 to 15, 10 oh my god, can't talk anymore. For the long term, 10 to 50 years, positive impact would be energy price flatlining. By removing peak pricing and curtailment, energy becomes a stable, low cost utility, fueling a new industrial revolution. Economic centralization. If a single company or state controls the PEP or potential energy pool, they hold energy sovereignty over others, leading to potential trade imbalances or storage wars. The arbitrage engine. The primary long term economic driver is time shifting. Leviathan buys negative price energy when the sun or wind produce too much and sells it during scarcity. This stabilizes the global economy by removing the volatility of fossil fuel markets. Environmental impacts. In the short term, first 1 to 5 years, positive impacts would be carbon sequestration. The massive Bio-Sifter kelp forests immediately begin absorbing megatons of CO2 from the atmosphere and ocean. Negative impacts in the first 1 to 5 years would be localized ecological shock. The construction of the Caldera and the deployment of sifter anchors disrupts seafloor habitats and local land use. I wonder how it's projected they can adapt. Long term, 10 to 50 years, fossil fuel retirement is a positive impact in the first 10 to 50 years. The existence of a terawatt-hour buffer allows for the permanent decommissioning of coal and gas peaker plants globally. Cool. Reducing CO2 emissions worldwide. The bycatch risk. Long-term stripping of trace minerals such as vanadium and molybdenum from ocean currents could create a biological desert downstream for nitrogen-fixing bacteria. The secondary bloom effect is a unique long-term positive, the secondary bloom effect. A unique long-term positive is the bioshield. If managed correctly, the sifter forests act as artificial reefs, increasing local fish populations and protecting coastlines from storm surges, turning an industrial mining operation into a coastal defense system. Bam, that's actually pretty cool. Right on. Societal impact summary. The safety versus security trade-off. The risk of sacrifice zones. Society must decide if it is ethical to place the risk of an acid breach on one local community to provide clean energy for an entire continent. Yes. Energy democracy. On the positive side, Leviathan could end energy poverty in remote regions by providing a stable grid that doesn't rely on expensive imported diesel. Final project summary and rating. We have traveled from the molecular oxidation of vanadium to the global politics of the Planetary Energy Accord. The Leviathan or Project Caldera is a high-risk, high-reward vision that defines the great transition of 2026. Innovation, 98 out of 100. Viability, 84 out of 100. Ethical integrity, 92 out of 100. And overall rating jumps up to 91 out of 100. We got an A now. Sweet. Final thought: the Leviathan is more than a battery. It is a monument to the era when humanity decided to stop consuming the Earth and started collaborating with its systems. We move on to a decision tree analysis where we employ systematic decision trees to map out and evaluate different courses or different choices and their potential outcomes. For the technology decision tree, the extraction engine, the first choice determines your entire supply chain and environmental liability. Branch A, chemical sifting, the traditional method. Result, high purity and faster scaling. Consequence, higher operational expenses, or OPEX, operational expenditures, including chemicals and filters, plus higher regulatory scrutiny for industrial runoff. Branch B, biosifting or genetically modified kelp. Result would be lower energy cost and would be carbon negative. The consequence, longer lead time or growth cycles, plus potential for genetic escape liability. You have the genes going through the ocean, getting into other species and manipulating them and affecting them positively, negatively. More likely negatively. Oh my god, I lost my place. Biosifting. Okay. Winning path. If your goal is net zero compliance, the tree points to biosifting. Investment decision tree, the funding stack. How you fund the $380 billion determines who controls the master key of your continent's energy. Choice 1, private equity, venture or PE, private expenditures or investments. Outcome, faster execution, but high demand for ROI, or return on investments, which would be 12 to 15% annually. Risk, short-term profit goals may lead to skimping on expensive safety liners. Don't do that. Yeah, no skimping. Maintain safety protocols at all costs. Maintain safety compliance. Choice 2, sovereign wealth funds or SWFs. The outcome would be 50-year patient capital, lower interest rates from lower interest rates of about 4 to 6%. Risk, the project becomes a political tool for the host nation. Winning path, for an infrastructure asset of this scale, the tree favors sovereign wealth funds for long-term stability. Risk decision tree, the breach protocol. What happens if the Argus 5 satellite detects a structural anomaly in the potential energy pool or PEP Caldera? Detection, anomaly confirmed. Option 1, attempt in situ repair or robotic. Success, project continues with minimal downtime. In the event of a failure, the leak accelerates during the repair attempt. Option 2, immediate level 3 discharge or emergency neutralization. If successful, the environment is saved and there is no toxic spill. If it fails, $30 billion worth of electrolyte is lost to neutralizing foam and the grid goes dark. The winning path, the security AI is programmed to take option 2. In the Leviathan framework, the environment is a non-negotiable asset. All right. Summary of decisions. For extraction, the primary choice would be the Bio-Sifter or Kelp, and the secondary backup would be chemical polishing through the refinery. For funding, the primary choice would be sovereign bonds, and the secondary backup would be infrastructure equity. For security, the primary choice would be satellite overwatch, and the secondary backup would be ground-based IoT sensors. And for containment, the primary choice would be salt domes, which would be self-healing, and the secondary backup would be lined granite caverns. lined granite caverns. This decision tree analysis shows that the most viable version of Leviathan is a state-backed, biologically mined, salt-stored engine. It is the most resilient against both physical failure and economic volatility. We have successfully mapped out every dimension of this project. The science, we use vanadium redox and genetically modified kelp. For security, we use air-gapped AI and Argus 5 satellites. For finance, we use SWF or sovereign, what was it? Sovereign, damn it. Sovereign wealth funds. There we go. I was thinking it was wealth. I was like 100% sure. So SWS or sovereign wealth funds or sovereign wealth fund bonds and arbitrage revenue. For ethics, we use the Planetary Energy Accord, which would be our own invention in collaboration with other nations to make sure that everybody's on the same page. Like, we would collaborate. We're not just going to do this all in secret like some James Bond villain. Like, no, we'd be transparent. We'd make sure that people were like fully informed what's going on, what we're doing, what we intend to do, what we intend to use this for, what it's composed of, all the stuff, all the safety mechanisms and contingency plans in place. All right. Now, for a few different elevator pitch options. Elevator pitch and executive summary. Cool. So, we need to create 3 different elevator pitches, each highlighting different strengths and aspects of the concept. To pitch the Leviathan concept of the Leviathan project or Leviathan concept of the Caldera project effectively, you must adopt your message to the core values of your listener. Whether they care about planetary survival, national stability, or long-term ROI, returns on investments, these 3 pitches frame the project as the inevitable solution to the energy transition's biggest hurdle. The Planetary Guardian pitch, best for environmental NGOs, green philanthropists, and the public. Focus is on sustainability, carbon sequestration, and ecological harmony. Renewable energy has a storage problem, and the mining for the solution is killing the planet. We're building Leviathan, the world's first living battery. Instead of destructive mines, we use genetically engineered kelp forests to breathe in carbon and sip vanadium directly from the ocean. We store that energy in massive, safe, liquid reservoirs that can power an entire continent for a week. We aren't just building a battery, we're coating a planetary organ that stabilizes our climate while it stabilizes our grid. The sovereign security pitch, best for government officials, defense strategists, and utility regulators. The focus is on grid resilience, national sovereignty, and strategic reserves. Right now, our national grid is one extreme weather event or cyber attack away from a total blackout because we lack long duration storage. Leviathan provides a 1,000 gigawatt hour strategic energy reserve that is physically unhackable and seismically secure. By harvesting vanadium from the sea and storing it in deep, self-healing salt domes, we eliminate dependence on foreign mineral chains. It's more than a utility. It's a great wall of energy that ensures our nation stays powered no matter what the 21st century throws at us. The financial trailblazer pitch, best for sovereign wealth funds, institutional investors, and venture capital. The focus is on LCOS, or levelized cost of storage, asset longevity, and market monopoly. The $4 trillion energy storage market is currently limited by the 10-year lifespan of lithium. Leviathan is a 50-year infrastructure asset with a levelized cost of storage that's 40% cheaper than any competitor. Our Bio-Sifter technology turns the ocean into a free mineral supply chain, while our Caldera-scale reservoirs provide a massive arbitrage engine. We're inviting you to lead a $380 billion project that doesn't just store energy, it captures the volatility of the global energy market and turns it into a stable, multi-generational dividend. Now for the pitch comparison matrix, for the Guardian pitch, the hook is stopping dirty mining, the core value is restoration, the key metric is it is carbon sequestered, and the emotional tone is hope and innovation. For the Sovereign pitch, the hook is preventing total blackouts, core value is resilience, the key metric is days of backup, and the emotional tone is duty and security. For the Trailblazer pitch, the hook is the 50-year market dominance. Core values are ROI and stability. Key metrics are LCOS and dollars per megawatt hour. And the emotional tone is vision and precision. Final project conclusion for the elevator pitches, at least. The Leviathan project is a civilization level answer to a civilization level crisis. By combining the precision of CRISPR, the stability of redox chemistry, and the scale of geologic storage, you have designed a system that moves humanity from extracting from the earth to balancing within it. Now, executive summary. Here we go. After everything we've discussed in this conversation, we will provide a executive summary outlining the key points of this entire concept. Executive summary for Project Caldera by Leviathan Mining Company. Leviathan is a revolutionary planet-scale energy ecosystem, or Project Caldera is a revolutionary planetary-scale energy ecosystem designed to solve the two greatest hurdles of the 21st century energy transition: long-duration energy storage, or LDES, and sustainable mineral sourcing. By integrating synthetic biology, redox chemistry, and geological storage, Leviathan moves beyond the limitations of lithium-ion technology to provide a continental-scale energy buffer. Core technological pillars: the Bio-Sifter harvest. Utilizing CRISPR-edited genetically modified, or GM Kelp, the project extracts trace vanadium directly from oceanic currents. This biomining process replaces destructive terrestrial mining with a regenerative carbon sequestering marine forest. Vanadium Redox Flow, or VRFB chemistry. Unlike traditional batteries, Leviathan stores energy in a liquid electrolyte, vanadium-saturated sulfuric acid. This chemistry is non-flammable, has a 50-year lifespan, and experiences zero capacity degradation over tens of thousands of cycles. Geological reservoirs: the lake. Energy is stored at a terawatt-hour scale, or 1,000 gigawatt hours, within massive subterranean salt domes or stable hard rock calderas. This provides a strategic reserve capable of powering a continent for a full week. Operational and security infrastructure: Argus 5 satellite constellation, a dedicated orbital network providing hyperspectral leak detection and SAR structural monitoring with millimeter precision, linked via unhackable quantum key distribution, or QKD. Air gap security AI, a localized paranoid artificial intelligence governed by a ethics verification model, or EVM. It manages grid balancing while maintaining a hard stop physical failsafe to prevent environmental breaches. Nexus Dispatch Hub, a centralized command center that treats continental energy as weather, using predictive algorithms to buy excess renewable energy at near zero cost and discharge it during peak demand. Financial and strategic outlook: capital investment estimated at $380 billion. Capital expenditure, or CAPEX, funded through sovereign energy bonds and green infrastructure funds. Economic viability: while the upfront cost is high, Leviathan offers a levelized cost of storage, or LCOS, approximately 40% lower than lithium-ion over its 50-year lifespan. Revenue model: derived from high-volume energy arbitrage, grid stability services, and the sale of surplus vanadium harvested by the Bio-Sifters. Risk and ethical governance: the primary energy accord, an international regulatory framework ensuring no single entity holds a terawatt monopoly and mandating open source audits of the security AI. Environmental failsafes includes genetic kill switches for genetically modified kelp and self-healing salt dome containment to prevent acidic contamination of the water table. In conclusion, Project Leviathan or Project Caldera represents the shift from extractive energy, burning the past, to circulatory energy, balancing the present. It is a high stakes, high reward infrastructure project that provides the physical and digital foundation for a truly 100% renewable global civilization. All right, and then a few hashtags. Should I read these? Yeah, I'll read them. Hashtag Project Leviathan, hashtag The Living Battery, hashtag Bio-Sifter, hashtag Living Infrastructure, hashtag Prime Planetary Organ, hashtag Cleantech, hashtag Energy Storage, hashtag Long Duration Energy Storage, hashtag Grid Modernization, hashtag Renewable Energy, hashtag Vanadium Redox Flow, hashtag Future of Energy, hashtag Energy Independence, hashtag Strategic Reserve, hashtag Sovereign Security, hashtag Infrastructure Investment, hashtag Energy Arbitrage, hashtag National Security, hashtag Carbon Negative, hashtag Ocean Conservation, hashtag Sustainable Mining, hashtag Beyond Mining, hashtag Climate Tech, hashtag Regenerative Energy, and hashtag Eco Innovation. Eco Innovation. All right, so that is the PEP, Potential Energy Pool for Project Caldera under Leviathan Mining. Presented by Leviathan Mining. All right. Sweet. 2 hours, Jesus. I thought it was going to take me like half an hour. Nope. All right, well, we got it all covered. We got it all done here. Right on. Right on, right on, right on. I love it. Made some progress today. I finished my pizza. Oh no, I need to make more. I finished it. All right. I'm gonna go get some food. I've earned it. Thanks for watching. Bonsoir.